Okay, hey, example 7, I'm doing it completely on the calculator, completely. All right, we got from 0 to 15, and we're given velocity, and it asks when acceleration is equal to 0. Now, hold on. If acceleration is equal to 0, that means that's the slope of the velocity curve. I want to know when that's equal to 0. Your calculator will tell you that. All right, so here we go. Let's see. I'm going tangent, and it says cube root, so let's go math 5. And so we got a cube root. There's a cube root button too, I know. X minus 0.2, and I'm using X again. And we're going to graph that bad boy. All right. So let's graph that. But we're supposed to be graphing from 0 to 15. So let's see what it looks like. All right, not bad. Let's change that window. Let's have the that go up to 16, I guess. I kind of have the same beginning part as I had on the last one. So graph that. All right. Okay, so the question is then, when find the time when the acceleration is equal to 0. Okay. All right, so let's do that. That's when I want the slope to be 0. Well, the slope will be 0 whenever this thing has a maximum. It looks like there's not a minimum as I go through here, so it must be happening in there. All right, so here we go. So let's go second, calculate a maximum. Let's go from 0 and I guess to 15. All right, and then find it, and there it is. All right, so find the time when the acceleration is 0. I just did that. All right, so, and I think I'll just type it. All right, what does that mean about the velocity at that moment? Okay, so here we go. All right, the acceleration throw any in there of the particle is 0 at t equals 2.1517. All right, 2.1. All right, and what does that mean about the velocity? All right, the velocity at that moment stops increasing. As I can see, it was positive slope before that, and begins to decrease. Okay. All right, at t equals 6 is what is the velocity and acceleration, and is the particle speeding up or slowing down? Oh, okay, that's not too bad. All right, so let's see. We're on the velocity, so let's do a trace here at 6 and see what's happening. All right, so it's definitely above the x-axis, and it's also going down. And to be sure that it's going down, I could calculate that slope. Look at there. All right, so, oh, it tells me everything right there. All right, so what I got? So a v of 6 is 0.7096, and the acceleration, or v prime of 6, the slope, is negative 0.1489. Okay. Since the velocity and acceleration have opposite signs, the particle is slowing down at t equals 6. There you go. Calculator completely. So again, if I've given a velocity graph and I want to know when the acceleration is equal to 0, I'm looking for a max or a min. I'm looking for a moment where the velocity stopped going up and it started going down, or stopped going down and started going up. Either way. All right. And so those can be found at max and mins, and your calculator will find those for you. That's pretty convenient.